Hello students and subscribers, here is an example on indeterminate beam by slope deflection equations. So analyze the beam shown by slope deflection equations. EI is constant. So let us show, although I already solved this using three moment equation, and this is the answer. So let's verify using slope deflection equations that the answer is the same. So here is the given beam. Take note that AB is an end span with A expected zero moment because it is a pin support and it is the last support, leftmost support. BC also is an end span with C ruler support, so moment at C is zero. So when we consider segments of a beam and one of the ends of the beam is expected to be zero, then the formula is 3ai over L for the moment. Moment near is 3ei over L, quantity theta near minus delta over L. And if we consider support points, then delta will just be zero. So MBA therefore is equal to, by the way, plus fixed end moment near minus 1/2 fixed end moment far. So again, moment when the far end or one end has zero moment is 3ei over L, quantity theta near minus delta over L, and delta will just be zero if we consider supports that do not settle, then plus fixed moment near minus 1/2 fixed moment far. So MBA therefore is 3, assume EI is 1 because it is constant over L10 for AB. Then quantity theta near is the first letter here, so B minus delta over L is 0 as already explained. Plus fixed moment at B, the near end, because B is in the right considering AB, the fixed moment due to the load is positive. So we have integral, I'll call this X. So integral from 0 to 8 of differential P, which is 25 dx, times A should be the distance from the near end to the strip. So this is treated A, which is 10 minus X. Then square of B, this is B supposedly, X square all over L square. Then minus 1/2, since the fixed moment at A due to the load is expected negative. So minus 1/2 of negative as explained. When the first term is positive, the second term should also be positive. When the first term is negative for a fixed moment, then the second would also be negative. In short, the two terms should have the same signs. So minus 1/2 negative, so all you have to do is copy and interchange the squared factor here. So 10 minus x is now square, and x will just be raised to 1 all over 10 square. So simplifying, and you can evaluate this using your calculator. The integral 3 over 10 is 0.3, so we have 0.3 theta b plus 272 combining these integrals here. MBC on the other hand is B is a near end, and the expected fixed moment at B is negative because it is in the left, and the expected fixed moment at the right is positive. So 3EI, 3 times 1 over 8, the formula is this because the far end is expected to have zero moment. Then theta near, theta B minus delta over L, which is 0 as already explained. Fixed moment at B is negative P A B square over L square. So P 45A should be 5. The distance from the closer end, near end, B is 3, so 3 square over 8 square. Then minus 1/2 fixed moment at C is positive. And all you have to do is copy this, interchange the squared factor. So 45, 5 square times 3, then divided by L square, 8 square. Simplifying, it is 3/8 of theta B minus 7,425 over 128. So since we only have one unknown, theta B, so apply equilibrium at B, MBA plus MBC equals 0, MBA plus MBC equals 0, equilibrium at B. MBA is 0.3 theta B plus 272 plus 3/8 theta B, 0.3 plus 3/8 is 0.675, and plus quantity 272 minus 7425 over 128. The result is transposed to the right, so which is become 7425 over 128 minus 272. And theta B can now be computed. It is negative 1369.55 over 432 EI. So there is EI here because we assume EI to be 1 there. So this is the exact value because we write it in fraction. Then the moment at B, which is moment BC, substitute in formula BC, 3/8 of theta B, so 3/8 of 3 times EI supposedly, so cancel EI. So 3/8 of negative 138,955 over 432 minus 7425 over 128. So the answer is in fact negative 176.892 kilonewton meter. So that's it for this video. I hope that you were able to understand the explanation and the solution.